At this point, we're ready to move on to other concepts that are very important in learning about hypothesis testing. And that begins with the concept of one-tailed, left or right, or two or both tail test. So, in particular, what you need to know is this. When you are asked, is it a left or right one-tailed test, or is it a two-tailed test? All you need to concern yourself with is the alternative hypothesis. So, the alternative hypothesis holds the key to determining whether you have a one-tailed test or a two-tailed test. Now, although we've considered some examples before, let's see this again, just to affirm what we already understand. The alternative hypothesis here says that the population mean can be less than 5. That means it goes in only one direction, strictly lesser than 5. So the type of test here is a 1, or since the arrowhead is going in the direction of lesser than, that will be values to the left of 5. So it's a 1 or left-tailed test. And in particular, it's a test about a parameter or a characteristic of the population, and that is the mean. Done. And since it's left-tailed, we expect the all probability areas of consideration to be on the left, both the p-value and the alpha, the level of significance. We will talk more about the level of significance later. Then, for the second question, you have the proportion greater than 0.2. So this would be all values of the proportion greater than 0.2. This is also a 1 this time, right? Since it's going to values greater than 0.2, that will lie to the right of 0.2. So right-tailed test. And this is about the testing a statement about the population proportion. And since it is on the right, we expect eventually all probability considerations to be on the right. We will talk more about this later. Flow with me and you will see where we're going. Then for the last one, you have the population proportion not equal to 0.5. If it is not equal to 0.5, it means it could be greater or it could be lesser. So this is a case of a two or both tailed test about what parameter? The population proportion. So we expect both tails to contain the split probability. So now that I've done that, you're welcome to pause the video and try these two examples on your own, and then afterwards unpause the video and watch as I also complete it. So assuming you paused the video, here we go with the corrections. So I need to decide whether this is a left, right, or two-tail test. I will simply go to the alternative hypothesis. I see the mean is greater than 10.7, so that will be in only one direction. So, and that direction is to the right of 10.7, so I can shade here. And the parameter being tested is no doubt the population mean. Example 2, or the next example. The same prompt. Is this test a right-tailed test, a left-tailed test, or a two-tailed test? And what is the parameter being tested? So in this case, looking at the alternative hypothesis, I can see that this is saying that the population proportion is not equal to 0.39, which means it could be greater than 0.39 or lesser than 0.39. So this is definitely a two-tailed test, both on the right, greater than, or on the left, lesser than, and the parameter being tested, no doubt, is the population proportion. Now that we know how to handle or tell how many tails a test has based on the hypothesis, based on the alternative hypothesis, It is now time to look at how to state conclusions correctly in hypothesis testing. We are going to need this down the line. So let's make sure that we cover our base very well. In the first example, we're told that suppose the null hypothesis is rejected. Well, we don't know what the null hypothesis is yet. That will require reading the context of the problem. So let's go ahead. We are to state the conclusion based on the results of the test. What test? Let's see. 6 years ago, 12.4% of registered births were to teenage mothers. A sociologist believes that the percentage has increased since then. Immediately I see this, the first thing I'll think of is this is a claim made by the sociologist. If it is made by the sociologist, this claim needs to be tested based on sample data collected as to whether it is true or false. So this claim that needs to be tested definitely goes to the alternative hypothesis, since it is always the research or test hypothesis. And what does it say? The percentage P has increased. Increased would mean it has become greater than what it was before, which is 12.4%. Okay, so if I've set up the alternative, then it is easy in this case to state that the null hypothesis must have been that it was formerly existing as 12.4%. So now that I have the null and the alternative hypothesis set, I have to remind myself that the alternative hypothesis is the one I want to test, is what I want to test if the sample data that's just been collected, the fresh sample data, provides sufficient evidence for this alternative hypothesis that I want to test, which is the claim. So, based on this, we were told, however, that after conducting the whole statistical analysis, we were told that the null hypothesis was rejected. That means this is gone. Well, if it is rejected, the only other option I can take, that is why it is called the alternative hypothesis, is H1, which is the alternative hypothesis. In other words, it was rejected because in the sample data, there was enough evidence or sufficient evidence to support the claim of the sociologist. So I am ready to state a conclusion then. The conclusion is as follows. Since we rejected the null hypothesis, that means that the only other implication is that when we tested the sample data, we had enough evidence in that sample data to conclude on the alternative hypothesis. So we conclude that there is sufficient evidence based on sample data evidence to claim that the percentage P has increased from 12.4%. We proceed to the next example. In this example, we have to state the conclusion based on the results of the test. According to the Federal Housing Finance Board, the mean price of a single-family home 2 years ago was $299,100. A real estate broker believes that because of the recent credit crunch, the mean price has decreased from that amount since then. Well, after the analysis of the sample data, the null hypothesis is rejected. Our goal is to state the conclusion correctly. Let me walk you through the process. If I were working on this problem, my first step would be to state my null and alternative hypothesis. In this case, I can see that a claim was made by the real estate broker that the mean price, so this is about the mean. I'm going to write mean. So the mean price has decreased. Decreased in statistics will be less than. Remember, since this is the claim, it goes always to the alternative because that is the one we want to test if sample data evidence, if sample data analysis provides sufficient evidence in support of it. Okay, so with that said, I continue. So I want to check if the mean price, mu, has decreased from what? What it used to be, the status quo. So that would be 299,100 goes here, and this is equal to 299,100. So based on this fact, I have now set up both what? The null and the alternative hypothesis. At this point, I can now follow through with what I was told in the question. I was told that the null hypothesis is rejected, which means the winner is the alternative hypothesis. In other words, this must have been that after the analysis, there was enough evidence for what we wanted to test. So we have a similar conclusion to what we had earlier, which can be stated as follows. So the conclusion would be that since the null hypothesis was rejected, we conclude that there is sufficient evidence in support of the claim of the real estate broker that the mean price has decreased from $299,100 since then. You might begin to ask at this point in time, what kind of analysis was conducted before we reached this conclusion to reject the null hypothesis? That is answered on the next page. And we want to learn here how to draw conclusions in hypothesis testing using two tools, that is, the test statistic and the critical value. To give you a heads up, we're going to learn later how to compute the test statistic and the critical value. But for now, let's see how we use them eventually. And to begin with, let's take an example. Summit Projects recently redesigned a client company's website and wants to show that sales have increased. Can you demonstrate that your expensive redesign has had the result you promised? I have selected 58 sales records, this is your sample data, at random from 2,000 of your company's access logs. I find a mean amount of $26.05 with a standard deviation of $10.20. Note that your question amounts to testing the hypothesis that the mean is $24.85 as it was before the redesign against the alternative that it has increased from that base amount. Given a significance level of alpha equals 0.1, that since this is 10%, it means we're conducting this test with a confidence level of 90%, a test statistic value of 0.896, and a resulting critical value of 1.328. We're to make a decision based on the test statistic versus the critical value and state your conclusion. The first step here is to take note of your null hypothesis, which is claiming that the mean amount that you have here is still 2485, 2485 versus the alternative that the mean is now more than that previous amount before the redesign. Then the next step is to draw what looks like the normal distribution, and then how many tails does this test have? It is time to use it. So we go to the alternative. This has one tail and it is in the right direction. So if it's in the right direction, I'm going to shade it. So this shaded direction on the right is called the rejection region. Henceforth, I'm just going to call it the RR region, that is the rejection region. There is a point here at which we cut off that value. So that values above it falls in the rejection region and values below it falls in the non-rejection region or the acceptance region. So as it stands, this value right here that cuts off the rejection region is this critical value. So what is the critical value in this case? It is 1.328. So on the number line, 1.328 is right here. Then I need to now decide where does the test statistic fall relative to the critical region, to the critical value rather? Well, without mincing words, we observe that 0.896 is lesser than 1.328, so it should come before reading from left to right. So what we find here is 3. 0.896 does not, keyword, does not fall in the rejection region. Well, if it does not fall in the rejection region, it is telling you one thing. Since it does not fall in the rejection region, this means you do not reject the null hypothesis. Some people would say fail to reject the null hypothesis. This means the same thing, and that is okay. So this time, you observe that the winning one is the null hypothesis. Since we're not rejecting it, we're embracing it. It means we do not, this time, have enough evidence for the alternative hypothesis that we wanted to test. So we draw a conclusion then. So what this means that we do not reject the null hypothesis is that we don't have enough evidence in the sample data to conclude on the alternative hypothesis. So this means we do not have sufficient evidence in support of the alternative hypothesis, namely that the mean has increased from 24.85. This means the sample data is saying that your redesign has not increased the mean, that has not increased the sales at all. So we proceed with that to the next example. In this case, according to a certain government agency for a large country, the proportion of fatal traffic accidents in the country in which the driver had a positive blood alcohol concentration, BAC, is 0.33. Suppose a random sample of 114 traffic fatalities in a certain region results in 51 that involved a positive BAC. After analyzing this data, a test statistic of 2.67 and a critical value of 1.282 was obtained. Based on this sample statistics, can we say that the sample evidence suggests that the region has a higher proportion of traffic fatalities involving a positive BAC than the country at the alpha equals 0.1 level of significance? To answer this problem, step 1 would be to write the null and the alternative hypothesis. I am looking for a claim, if any, that was made. Well, this is asking, can we say that the sample evidence suggests that the region has what? A higher population of traffic fatalities. Once I hear the word higher, this is a comparative language. So we're interested in proportion. So I'm going to write PP. So I want higher proportion. Higher will be greater than something. Well, if we read back, we were told that in the large country, the BAC was 0.33. So it must be that we are interested in whether this region has a higher or greater than 0.33 BAC. So if that is the case, this is what we want to test if this data provides enough evidence for. So this will be competing against the null hypothesis that it is equal to 0.33. Now that I have my hypothesis set up, the next step would be to draw my shape and then to note that in this case again, I appear to have a one-tailed right tail test. So I will again shade my rejection region. This is my RR, and I need to locate the cutoff point here. That cutoff point always is your critical value. So 1.282 is right here on the number line. And if that is the case, the next thing I need to check now is, where does the test statistic fall? Does it fall on the left or does it fall on the right? 2.67 is definitely a number bigger than 1 point, excuse me, bigger than 1.282. So it definitely falls on the right, which lies again in the rejection region. Whoops. So since it lies in the rejection region, remember the previous example does not fall in the rejection region. So we did not reject the null hypothesis. What do you think will happen? So since 2.67 falls this time in the rejection region, RR, that will cause me to reject the null hypothesis. That means that as far as this sample data is concerned, it is telling me this is no good. And that means in return, I have enough evidence for the hypothesis I wanted to test, namely the alternative hypothesis. So my conclusion will be as follows. The first step will be that we reject the null hypothesis. And if we reject the null hypothesis, that means there's no need to rewrite that. So we conclude that we have sufficient evidence for the alternative hypothesis. Sorry about that. I mean to say we conclude that we have sufficient evidence for the alternative hypothesis. In full, we can say that this conclusion goes as follows. We conclude that we have sufficient evidence in support of the alternative hypothesis, namely that the region has a higher concentration than 0.33 of traffic fatalities than the entire country. So what we have learned so far is how to draw conclusions based on the test statistic versus the critical value. This is one possible route. I will emphasize this. This is one possible way to draw conclusions. Another way is depicted or illustrated on the next page. That is using the p-value and the level of significance of the test, which is represented by alpha. We will talk more about what alpha means, but for now, we want to see how we use the p-value and the level of significance of the test to draw conclusions. To illustrate how we do that, we take the first example. It's a boy genetics lab claims that their procedures improve the chances of a boy being born. The results for a test of a single population proportion are as follows. You have the null hypothesis claiming that the proportion is equal to 0.5, evenly split, and the alternative claiming that the proportion or the percentage of having a boy is greater than 0.5. We're given alpha equals 0.01, the level of significance of the test to be 1%, and the p-value is 2.5%, 0.025. We are expected to use this to interpret the results and state a conclusion. Here is how we go about this. There is a rule we use, a golden rule all over the world, and it says that anytime the p-value is lesser than alpha, the level of significance of the test, you should always reject the null hypothesis. This is true in statistics everywhere. This is like a formula to note. So otherwise, and this otherwise means that if the p-value is greater than alpha, we do not reject the null hypothesis. So in this case, here is our way to draw a conclusion. What is our alpha? Alpha is 0.01, p-value is 0.025. So, do you think this is a case of p-value lesser than alpha? What do you think? 0, 0, 0, 0, 1, 2. 1 is less than 2. So this case, you see that alpha is greater than, alpha is lesser than p-value in this case, rather. So it stands to reason that what we observe in this case is that since or let me first write it this way, the p-value of 0.025 is definitely greater than 0.01. So as it stands, this is the case of otherwise, which is the p-value is greater than alpha, so we do not reject the null hypothesis. So we do not reject the null hypothesis. So let's make a conclusion. So since p-value is greater than alpha, do not reject the null hypothesis, which means this is the winner this time. The null hypothesis is the winner, and that means we have insufficient evidence for the hypothesis we want to test. So since the p-value is greater than alpha, we're not rejecting the null hypothesis. That means we don't have enough evidence for the alternative. That is, what that means is that we do not have sufficient evidence to claim that the population or the percentage or the proportion of or the probability of increasing the chances of a boy being born is greater than 0.5. That is, the lab improves the chances of a boy being born is not true. Then, in the next example, we are told that in a clinical trial, 28 out of 885 patients taking a prescription drug daily complained of flu-like symptoms. Suppose it is known that 2.9% of patients taking the competing drugs complain of flu-like symptoms. Is there sufficient evidence to conclude that more than 2.9% of these drugs users experience flu-like symptoms as a side effect at the alpha equals 0.1 level of significance and a p-value of 0.320? Again, we start off with what do we have as the null and the alternative hypothesis in this case. We are trying to find if this claim that more than 2.9% experience flu-like symptoms. So this is about a percentage. So I'm going to write P more than 2.9% versus the null hypothesis that P is equal to 2.9%. So our interest here is we're going to follow the same decision rule since we're using alpha and P value. So same decision rule in this case. And we need to observe. And in our observation, what do we observe? For the p-value was 0.320, and alpha, the level of significance of the test, was 0.1. What do we observe? Is this less than or is it greater than? I believe 3 is greater than 1, so this is greater than alpha. So again, let's write the right conclusion. First, we argue that since the p-value is greater than alpha, that will be the case that we established earlier, which is it leads us to not reject the null hypothesis. So if we are not rejecting the null hypothesis, it means it's the good one. And that means, on the other hand, we do not have enough evidence for what we wanted to test. This means we do not have sufficient evidence to conclude that the percentage is now more than 2.9%. This p-value we've been talking about so far, it represents usually the probability of observing a sample statistic as extreme or even more extreme than the one that was observed under the assumption that the statement in the null hypothesis is true. You do not necessarily have to cram this definition, but you do need to learn how it is used to draw conclusions by following the decision rule.